The type system in TypeScript provides a way to specify explicit types for variables, parameters, and return values. This helps catch errors during development and makes the code a lot more self-documenting. Let's start with type annotations. Type annotations are used to explicitly specify the type of a variable, parameter, or return value. They enhance code clarity and help catch type-related errors early in the development process. A type is denoted by a colon and type name directly after the name of the variable. If we log these out, we can see that this still works like traditional JavaScript, right? We get num of 10, name of John, and an is valid boolean of true. However, if we were to try and assign a value that doesn't match the type, like say changing this number 10 to a string 10, we immediately see our linter doesn't like this. Hovering over the error, we can see exactly why. Type string is not assignable to type number. Even if we don't use the linter, we can still run this and see the same error in our log. The type string is not assignable to type number. TypeScript also offers a handful of built-in types for us to work with. Let's run through these. So we have number, which represents a numeric value, string representing a string value, boolean representing boolean values, and then we have the any keyword, which represents values of any type. Void represents the absence of a return value altogether. Null and undefined represent null and undefined values respectively, and then object, which represents non-primitive types. Be sure to review the TypeScript documentation for a full breakdown of what's available out of the box. In cases where TypeScript doesn't offer the type you're looking for, you can also define your own custom types. This is normally done using things like interfaces or classes. Look at an example of that. Let's say we have a person object, and it always has a name property and an age property. Here we can introduce an interface of person where we state that the name value should be a string and the age value should be a number whenever the person is built. Now, in our person object, we can assign the person type to ensure its consistency and integrity throughout our code. When we log that, we can see we get exactly what we'd expect. Now, similar to our first example, if we tried to change our age number to a string, we get an error. The exact same error we got before, right? Type string is not assignable to number. Next up, we have the union type. The union types allow a single value to be of multiple types. So for example, if we wanted our age property to be a string or a number, we could use the pipe operator to separate the types that we want. So age is now a string or a number. And we can see that after setting that in our interface, our error on the age property goes away, no matter if it's a string or a number. If we print this out, we get what we'd expect. Name of John, age of 20. Last but not least, we have our intersection type. Intersection types in TypeScript allow you to combine multiple types into a single type. This means that an object of an intersection type has all the properties and methods of each individual type in the intersection. Intersection types are denoted by the ampersand operator. Let's take a closer look. Say, for instance, we have two interfaces defined, printable and loggable. Both just consist of a single method where printable has a print method and loggable has a log method. Now let's create a method and set its type to our printable and loggable types we just defined. Keep in mind that this new method of ours has to create both a print and log method since its type is printable and loggable, which both require those methods respectively. That's why we're getting this error here. If we define those methods, that error goes away. From here, we'll define a new variable called logger and also assign its type to our custom printable and loggable types. Finally, let's use our new print and log methods. And that works exactly as we'd expect, right? We get printing log to the screen followed by logging log to the screen. Pretty cool, right? In summary, the TypeScript's type system provides a more structured and safer way to write JavaScript code by leveraging static types and advanced features.